Now we will do something even more interesting. Let's try to cut out a circle with the radius of half of the total row index. What I mean here is, as you see in this image, we will cut out this circle here, and we'll see how we'll calculate the Euclidean distance of all the points within a radius from the center. So to do this, to summarize, we'll need to calculate the Euclidean distance of all points from the center. And if you have a triangle like this, which is the long edge of the triangle from point x1, v1, x1, y1 to the center xy. The radius of the circle will be the Euclidean distance of any point. So x squared, y squared should be less than r squared. So how do we do this, right? So you have a nice image here in your notebook. Let's see how we convert what we mean and try to create a filter for all the points beyond that radius line, that circle, to be true, and all the points within that circle to be false. In these first two lines, in the next code block, we create two mesh grids. They will be called X and Y. But before that, we'll get the shape of our photo data, which is our ND array, which is 3-layer image, right? And we'll assign the number of rows to total rows, number of columns to total columns, and the 3 layers RGB to total layers. So if we actually go ahead and print this, we'll see that the shape is still that original shape of the image. Let's comment that out. Next, now we'll use the OGrid function to help us vectorize the distance from the center, which will be a function of the two variables. OGrid returns as an ND array. So what will OGrid return? We'll give the range of total rows and range of total columns, and it's going to give us, let's uncomment this line with the print, it's going to give us two vectors, x and y, which will have, the x will have the total number of rows, like the one that we give here, and y will have the total number of columns. So OGrid is a compact method of creating a multidimensional ND array operations in single lines. As we uncommented the two print statements here, we saw that x and y are vectors that match the number of rows and columns in our original image, respectively. Okay, I'll comment that out again to make our notebook compact. Next, we will now calculate the center point x and y and call them center row and center column. So total number of rows divided by 2, total number of columns divided by 2. We will use our two vectors, x and y, to calculate the points that are further than the distance of this radius of the circle we are trying to create here. It could be confusing, so please, again, feel free to stop the video and uncomment all these print statements that we have here to explore data in these vectors and the distance from the center matrix further. Okay? So here we have the distance from the center. We are using our center row and the x vector to create the distance from the center matrix. And we are going to make sure all of these values, or each value in this matrix that is greater than the radius is true, like here. We are trying to set all these circular values outside of the circle to be true in our circular mask. And we'll assign that to the circular mask. So actually, let's go ahead and run this. And if we print the circular mask, we'll only see the edges, right? We'll see that those edges in the matrix are indeed true. But if we go and provide a range query towards the center of the figure, which is the range selection in our second print here, row 1500 to 1700 and column 2000 and 2200. If we run this again, we'll see that those points or those pixels are indeed false. So we were able to identify what's inside the circle and what's outside the circle. Okay, now we have our circular mask ready here. We will go ahead and filter the image. I reload that original image again and use that photo data and filter it using the circular mask we generated and assign all those values to be 0, to be black. So just think for a second what you would expect to see in our original image when we plot this image. We are using the same plotting IMShow function to plot this. We'll see that we have this, our image nicely cut out as a circle. So nice work. Hope you were able to follow this. If not, please review what we've done until now before we move on. Okay, now let's combine this circular mask with another one that masks out now the bottom half of the image. So it's below any point below that center row point we had in this image, right? This is the center, and we assign that to a variable called center row, the x for that point. We'll now use that as a mask. We'll use the same technique to create a mask here. In x, our vector, any point or any row below the center point of the image will be filtered. So any x that's less than center row, that's the upper half, will be true. So we'll call that filter half upper. Okay? Then we'll use the logical AND function from NumPy to combine these two filters. I'll call this new filter half upper mask. I think we should have maybe called it half upper circular mask actually. And we'll provide the half upper and circular mask as the two filters to this new mask. So we are ending all the true false values in those per row column index. We should have a filter that gives us the true values for upper and around the circle. Now if we assign this half upper mask to this filter and assign the value of 255 to the points that are true in that filter, those parts should be visible as white in the resulting image. Okay. So let's apply our mask and plot our image. Oh, sorry, I didn't run the... Okay, and let's apply our image. We see that anything around the circle that's in the upper half is white. We could have used the random. For that, we'll have to import random. So please stop and uncomment that where we imported that random before. And this random int assignment. You should see the effect in the intensity values. We still select here, when we use the random integer, an intensity value of high between 200 and 255. but the color will randomly change. It's not going to be pure white. It's going to have a shade of white. So please stop the video and try that line and make sure you understand that part. Okay. Now let's remember the meaning of each of these RGB layers in this image. Remember, red was for altitude or height of that geographical point. And now we know how to create masks. We'll create one by selecting the red layer, which is layer 0 in our 3-layer matrix. And maybe we'll select anything of intensity higher than 150. So what I'm doing here is I reload the image, and I'll start creating the red mask. Here, I'm taking the photo data and selecting all rows and columns for layer 0, which is our red layer. And the red mask will have true for all the values in that photo data with the red layer of 150. So all the red values that are less than 150, the row and column index for those will be true in our red mask. Let's use this mask to assign 0 to all those points. So I'm going to run this, and we see that the image will be plotted, and we only display the high elevation areas. Our image changed quite a bit, actually, because we only show the points in the image that had that red intensity of 150 or higher. Next in the notebook, we do the same to find the high aspect and high slope. The only thing we change here is we change to green and blue layers. Please run those two code cells and observe how your image changes. It shouldn't be the same image. It should have differences based on elevation, slope, and aspect. So we are almost at the end here. I hope you're still having fun with me. Lastly, let's create a composite mask for a point with high elevation, high aspect, and low slope using the logical AND like we did for our circular and upper half. We are doing the red mask as we did before, green mask for points larger than 100, and blue mask for points greater than 100. Smaller than, less than 100. And our final mask will have these three combined using the logical AND function. And if we plot the image here, we'll see that those values, the image changed a bit again from the original one. And we filtered out the points with these three conditions. Hope you enjoyed this notebook. As an exercise, I suggest you to use a photo of yourself and create some interesting filters to create your own Instagram.